you're okay. So wherever you're joining from any part of the world, hi to you, and thanks for joining this class. So just give me a minute, let me share my screen before I give a brief introduction about the topic we'll be having. Okay. So let me know if you can see my screen. Can you guys see my screen?
Yes, we can see. I can see the screen.
Okay, cool. So today's topic will be based on asynchronous JavaScript. So I use the word async for short. Please feel free to
So, Brian, please unmute yourself. Okay.
Okay.
Sorry about that.
Yeah. So I'll go again. So I said that today's class will be asynchronous JavaScript. So I use the word async JavaScript for short. So the way I want this class to be is I would try to go as quickly as possible for the next 30 to 45 minutes, and then leave 15 minutes for as much time as possible for questions, because I know you guys might have a couple of questions. So while I'll be explaining, we'll be also writing some code to just give us more understanding about asynchronous JavaScript. So async JavaScript, yeah, so this is one of the most common words you hear about JavaScript, because JavaScript itself, it's an asynchronous language, and most of the operations you'll be doing which are JavaScript related should be asynchronous. There are very, very little times where you need synchronous JavaScript. So if you're not doing things the async way, it's almost like you're not doing it right in terms of JavaScript, because JavaScript is single-threaded. So what it means by JavaScript being single-threaded is that it can only perform one operation at a time, compared to languages like Java, Ruby, and the likes that are multi-threaded. But there's a caveat. JavaScript can perform more than one operation at a time, but you only need to know the fundamentals, how JavaScript works, which leads us to this. So in asynchronous JavaScript, these are some of the key concepts that make JavaScript asynchronous: callbacks, promises, then async await. So we're taking them one after the other. So first of all, before we go into asynchronous, we need to understand what synchronous JavaScript is. So in this short definition, it says that synchronous synchronous JS, in a synchronous programming model, things happen one at a time. When you call a function that performs a long-running action, it returns only when action has been finished. So normally, if we'd say, let's move to the code part. So if we have, say, a function like, I'll be using ES5. So if we have a function, say, synchronous, and maybe we run an operation saying that we can say in our first task, we can say maybe 2 times, or we can make this a variable. We can say var multiply is equals to 2 times 2. And then we can also run another operation, say var add number is equals to, say, 2 plus 2. So what synchronous means is that this would run first. The first, that is line 2, will run first, and line 3. Or an easy way to depict that is to go into our browser. So I'll be using the console on the browser because it's a better environment to understand asynchronous JavaScript. So we can say console, let me increase this. You can say console.log run task 1, and then run task 2. So this is synchronous. It means that the first one runs before the second one. So it's step by step. But in async JavaScript, things are a little bit different. We'll get to that part. So synchronous is just telling us that a program the program runs in a stepwise fashion where one runs completely before the other. Now, the disadvantage with that is that if we have a long running task, like a Fibonacci sequence, it blocks the thread because JavaScript is single threaded. And when we have like a difficult or say a very heavy task to perform, it blocks that thread. I can show you an example of Fibonacci sequence. Let's see. Fibonacci sequence JavaScript. So I can show you an example of a Fibonacci sequence. So this is a Fibonacci sequence here. We can use this. And if we run this, say, we can call this function again. If we pass a value of, let's say, 32, just look at how long it will take. So let me make this 42. You see, it's taking a while for the result to return. It took almost like 2 seconds. Now, imagine you're running like a heavier operation. It could take probably 10 seconds, which means that period while this sequence is running, the entire thread is being blocked and you cannot perform any other action. And that is why you have to run JavaScript.
Brian, for continue short. So I don't know if you can see the chat, but I think they are saying they can't see your screen. If you can see the chat from your end, yes, thank you. Sorry.
Okay. Sorry, guys. Okay. Sorry, guys. I will take that again. Yes. Okay. Can you guys see the console? Can anyone indicate if they can see the console? Hi guys, can you see the console before I continue?
Yeah, they're saying we can't see the screen. We can only see your VS Code.
Wow, that's weird. Okay, let me run this on my VS Code.
Or maybe you can zoom in so that they'll be able to see your screen better.
I think, okay, let me do something. Let me stop presenting and then let me stop sharing my screen and share my screen again. So can you guys see my browser?
Yes, we can.
Okay, cool. So I'll go ahead. Sorry about that. So yeah, I was trying to depict a situation whereby if you run like a heavy operation in JavaScript, it could literally block the thread. like I ran this Fibonacci sequence. So if you can see this, usually when you run things in the console, it returns your result almost instantly, but this might take a few seconds for this to return. So it took about 2 to 3 seconds. It means that the thread was blocked during that period. And in that period, it's almost like you cannot use that particular thread to run any task. So that's where the asynchronous part of JavaScript comes in. So in the synchronous aspect of JavaScript, you can run multiple operations at the same time. So one operation doesn't have to run completely before the other one starts. Like one can be running, another one will be running in the background. And at the end of the day, we can get our output at different times, depending on how long it takes each operations to occur. And one of the key concepts to asynchronous JavaScript that would help us understand how these operations run and how we can write better code, because the whole idea of asynchronous JavaScript is writing non-blocking code. So in JavaScript, you will hear concept like non-blocking IO, which means IO means input output. It means that you should not write code that would block your thread. So you should learn to take advantage of JavaScript asynchronous nature. And that brings us to the event loop. So the event loop is more or less what happens in the background when you're trying to benefit or trying to use that key aspect of asynchronous JavaScript. So here we start with our runtime environment. Our runtime environment, in this case, I want to use our browser because we are focusing on the front end. Your Node.js is another runtime environment, and it works slightly different from your browser. So to depict most of the key concept that we'll be looking at today, would prefer using our browser. So the event loop, which has the runtime environment browser, I'll be showing you some examples shortly, starts with the stack. So our stack is that part of our browser that executes our code. And we have web APIs. Web APIs is another component of our browser. And then we have our task queue. So the way this works is when you run a code, it goes to the stack, and then simple codes like this. So simple codes like this. Let me show an example. So we have something like console.log, or give me a second. Let me get a good example. So when we have a couple of, I'm going to run like a couple of code just to depict something here. So just to save us time, I would paste this here. I don't know if you guys can see my console before I go ahead to explain what happens here.
Yes, you can see
Okay.
it.
Okay, so if you look at this code right now, trying to understand the whole concept of asynchronous JavaScript. In the first line of things that run, we have a console.log that logs the number 1. And then we have a set timeout, which is an asynchronous code. And we have to set timeout. One will run after a second, and the other one will run almost immediately. And then we have the fourth code that will run, which is console.log. Now, surprisingly, the result we'd expect to get in terms of the order is supposed to be 1, 2, 3, 4. But the result we are going to get, by the time I click enter, you see shortly, and I'll explain why. We have 1, 4, 3, 2, and it took just about a second for the 2 to appear. So what's happening here is, and the console.log is just a pure synchronous code, and it runs almost instantly, which is run in the stack. And because set timeout is an asynchronous code, it is moved to the web API. part of the browser. Same for the other set timeout. And then the other one, the console.log 4 runs almost instantly. So if we look at this again, you see that code is being processed here. And then when the result is being churned out, it is moved back to the task queue. So the task queue is also another component of your web browser. So all these things are working behind the scenes. You can't really tell, but at the end of the day, you see your output, like your browser actually compute all these things and give you like a simple solution or a simple result rather. But in the end, what goes on is that your code goes through the stack. And if there's any API related code is moved to the API, by the time it is being processed, it is returned back to the task queue, and the task queue will push back the code to the stack only when the stack is empty. So that means console.log, let me open the, so that means that console.log would have to, let me show you the code. So both console.log will have to run first before the set timeout is being passed back to the stack. The console.log from the timeout is being passed to the stack. So that's the event loop, which makes JavaScript asynchronous. I want to go into more code, like just to give us like a little bit more understanding. So callbacks, like I mentioned earlier, callback is one of the key components to asynchronous JavaScript. And what callback is, callback could be any function. Callback basically is just a function. So let me give you an example of what callback is. So callback is, for instance, we have say function, or let me do this here. Function do something. Let's call our function do something. And our function takes a callback as an argument. And let's say this callback should, what do we want this to do? Okay, let's see, we can say that our callback should return, let's say should return a callback that, so our callback takes an argument, let's say add number. We can pass in, say, 2 numbers. Now, I'm thinking about a good example that we could use just to depict this. Or let's say our callback returns value, say I was called. So now we would define the callback below. Let's call this function example CB, and we can say that it takes an argument of string and it returns back the string. So it returns back the string. So what we are basically doing is we have a callback. This example CB is a callback. It takes an argument of a string and it returns back the string. So if we call this function, say do something, and then we pass in this example CB. CB in this case is a callback. So we can run this to see what we get in our console. So you can see I was called is being churned out because we passed this. So basically when you hear callback in JavaScript, what they are is just any function. So when you pass in a function as an argument to another function, the function you're passing in as an argument is your callback. So that's what callbacks are basically. And I just showed you an example of a callback. And then promises is in fact, the most fundamental part of asynchronous JavaScript, because when you run an async JavaScript code, what it does, first of all, is it creates a promise. And it is that promise that is then being processed into the final result of what you might be expecting. Or even if it generates your promise as your original data, you can also still manipulate that data further to generate probably a new type of data. So a promise is just a JavaScript object that serves as a placeholder for an actual value that you might tend to use in future. Like, for instance, you're making an API call. You don't know if the API call might be resolved or not, but the first thing that the JavaScript does is to make sure that your result comes in as a promise. And promise usually has two stages. It's either it's being resolved or it's being rejected. When it's being rejected, it's mostly probably due to an error. And when it's being resolved, it means that you actually have an existing value. Now that value is what you can process into the value that you consume as your final result. So I'll be showing you a couple of code samples just to, for you guys to understand the whole concept of promises. And let me do that on the VS Code. So we have some example. It can say there are different ways of creating a promise. We can create a promise by using a promise constructor. So if we do this, new promise, you say resolve, reject, we can say resolve I created a new promise. Another way to do this easily would be to say function promise example 1. We can say new, no, not using promise constructor. We can go straight to create a promise like this, promise.resolve. And we can also say I created another promise. So we're going to run this in our browser to see what it looks like. Okay, I need to call our function. Supposed to console.log. Oh, we are not returning the value. That's why we are getting undefined. So let me run this again. Or we can just run this using a variable. So what I'm trying to depict here is I'm trying to show you how a promise is being created. And you can see let's see from the code. We're supposed to get a promise here. We're supposed to, so the browser is supposed to show us that we created a promise. I think I'm missing something. So let me just take another look. Think, what am I missing? Okay, I think I found what might be missing. Let's see, you're supposed to return this value. It's supposed to be returned here. Okay, yeah. So this is it. You can see that this is the promise that was created and it shows fulfilled, which means that the promise, that's the result that we're expecting, was actually generated. So another way, like using the other example, we can generate a promise. So this has to be returned also. And promise example 1. The same thing. So we can either use the promise constructor or just create a promise directly using any of this. So basically what a promise is just like a placeholder. If I should, for instance, I want to, if I should say, if I want to show the different states of promise, I could do something like this. Like I could actually create a set timeout here. So I could create a set timeout. So what our set timeout does is, our set timeout is basically an API, and what it does is it takes a callback. So the function that you're seeing here is actually a callback. So you say return this. So if we run this, set timeout takes 2 arguments. One is a function and one is the amount of time that you want it to resolve. So if we run this, you see what happens. Oh, the same mistake. I'm supposed to return here. So you can see initially we have this pending, and then at some point it becomes fulfilled. So this pending is because we are using a set timeout. So when you use a set timeout, your result is still pending because it is still being processed. It's not yet computed in the stack where it's supposed to run. So after 3 seconds, then this pending now becomes fulfilled. But we are not going to see that like explicitly in the browser. But the reason why we get this status as pending is because we have a set timeout. So it means that the function doesn't run immediately. It waits after 3 seconds before it's being processed. If I should increase this to 5, you would see that, let me depict this again. Probably let me make it 5 seconds so that I can show you. So you can see that the result is still pending. And after 5 seconds, we now get our results. I think it should be 5 seconds already. The browser is not refreshing the result, but automatically after 5 seconds, it's supposed to, because I opened this before the 5 seconds elapsed, that's why we're getting this pending. But if I should run it without opening it and just count 1, 2, 3, 4, 5, Once I check now, I have my results there. It's fulfilled. But if I run it just immediately and open it, because the browser is not able to refresh the results, we'll see pending there. So promises are very, very key and essential to the JavaScript concept of being asynchronous, because it enables us to run multiple tasks. So while this is pending, other tasks can still be running on the background without blocking the JavaScript thread, since JavaScript is single-threaded. And lastly, we'll look at async await. So async await is more like a syntactic sugar. It's kind of a cleaner way of writing our code so that it could be clearer. And I'll show you where async await comes in. So for instance, looking at this code now, if you run this code, I want to set this to 0 so that it runs immediately. So if we run this code, we get this. It's a promise, right? And we can say that, or let me just take out the set timeout to depict what I want to show. This should return almost immediately. Now, this is a promise. The function here, promise example, is a promise, and we can decide to do various stuff with this promise. We can now say promise. We can call our function and say .then, and then we can pass a callback, or we can just write our callback. We can say that results. Let's say console.log. Let's say results. And we can now pass the rest here. You see what happens? So now the value I created a new promise. It's now living inside this function as a promise, and it's a value that we can manipulate in any way we want. So we can also append a new value to it. So whatever we choose to do with that particular value is up to us. But the first thing is generating that data in an asynchronous fashion, which is what your promise does. So your promise basically generates this data and puts it in this object, which is the promise object, so that you can use it in future, whichever way you choose to consume that data. And so the difference between probably just using the regular promise or using async await doesn't necessarily do the work of the promise itself. It's just a cleaner way of writing this code. So if I were to write this code using async await, I would do something like this. We can say, let me use the VX code. So let's say this is our example with a promise constructor and using async await. So we can say function promise waits async. Add our async here. And say turn to So I pass this promise into a variable, and we can call this, let's call this constant value. So instead of doing the .then that we did here, because like if we were to use this, we can say .then and then make this, I can say probably just return R, which will return this, or you can console.log it if you prefer. But in this case, rather than doing .then, we can choose to make this, we can say console.log, what do we, okay, let's say results. Wait, value, result with value, and then we can pass in our value. So if we call this, you see how, so we'll most likely get the same thing. Sorry, I didn't copy this. So you can see the same thing we did with the .then chaining. We can just, rather than probably using .then, when we use async, we can await and write like a cleaner version of the code. So then the value now lives in this value variable, excuse me. So that's what async await does. It's known as a syntactic sugar. It's just a better way of making your code cleaner. So because when you start doing maybe, this case, we can do a couple of .then. I can say .then, I can do another .then, and probably passing another callback. So mind you, this R, fat arrow R is a callback. It's just a short form. So we can do this. We can keep chaining as much as possible. We can decide to say, and probably say, no, it's already returning. Can do this. So return R with a value. We can still chain furthermore as much as possible. So rather than chaining continuously, using async await is like a cleaner way of writing this. So instead of doing this, we can just keep using this value variable and then writing a more cleaner code. So that's basically it in terms of this, like an introductory part to asynchronous JavaScript, because it's a pretty advanced topic, and I'm just trying to juggle as much as possible in terms of importance as to what you need to get started with asynchronous JavaScript. So first of all, you should know that JavaScript is single-threaded and it can easily be blocked. So you don't want to write code that would block your JavaScript thread, and that is where the asynchronous part of JavaScript is. So if you're writing asynchronous code, means that you're leveraging on JavaScript ability to run multiple tasks in the background. Although it seems like JavaScript can only do one thing at a time, but that's not so true. Because of the event loop, JavaScript can run multiple things at a time. So it will run the simple codes in the stack, and once that are synchronous, it will pass them probably to the API, and then the API processes it, returning back to the task queue. And then when all the synchronous code are finished running, the results of the asynchronous code is then pushed. Now, this task queue, you can see that I use this two acronyms here. That's two letters rather, CB, as an acronym for callback. So callback is the function that you pass to say an asynchronous code that will run after the result is being processed. So when you run an asynchronous code, like say a set timeout that we have here, the set timeout is being processed in the web API part. When it's being resolved, this is what is being returned. It is this block of code here that is being returned as a callback. And then that callback is now run back in the stack for you to get your final results. So that's fundamentally the concept of asynchronous JavaScript. I will take your questions as fast as I can. Please feel free to use the mic and let me get to the chats.
So, hello guys. If you want to ask a question, you can raise your hand. If not, drop it in the chat room.
Hello, Brian. Good evening.
Hello, can you hear me?
Yeah, I can hear you.
Yeah, go ahead, please.
Okay, so I wanted to ask about the set timeout. Because I noticed when you were trying to fix in the time at which it would take for the code to run, you used 3,000 for 3 seconds and 5,000 for 5 seconds. Like, why is that?
Okay, so in JavaScript, time is being measured in milliseconds. So if you use 3, you're referring to 3 milliseconds. So how many milliseconds makes 3 seconds? It's 3,000 milliseconds. Do you get me?
Yeah, I get you.
Okay, so yeah, so it's just because time is measured in milliseconds. So in JavaScript, we calculate time in thousands. That's for
Okay.
seconds. So 1,000 represents a second, 2,000, 2, and subsequently.
Thank you.
Any other questions? I could still shed more light on some of the key concepts. Like I know I had to rush through this, like this whole like the promise aspect, because when you're dealing with asynchronous JavaScript, you're mostly creating promises. So your promise is just an object, because everything in JavaScript is said to be an object fundamentally. Even your array is an object, apart from primitive values. Primitive values are primitive values, but every other stuff in JavaScript is more or less an object. So your promise is also a special kind of object. It's a place value, it's just a placeholder for any results, because we don't know what the result might be. We don't know the shape of the result. We don't know what the content of the result might be. It could be a number, it could be a string, it could be an array, it could be anything. So in that, before that result is being generated, a promise is being created. And then we can process it using .then, .catch. So I forgot to add this. So for instance, if we look at the promise that we created here, a good way of handling this promise, let's assume I want to consume the data and maybe an error occurs somewhere. So I will say R, this will return the data. But what if there's an error? It could crash my program. That is where .catch comes in. So .catch would always, you can pass in, you can use any variable you choose. Here I use error, and then I can say maybe console.log, console.log the error. So that's what the catch is for. So the catch helps us catch error. if we are using async await, we'll do things a little bit differently. In async await, we'll do something like this. We use try catch. We can say try, which will run the main block of code. And then if there is an error, try catch. If there's an error, you can tell it, you can decide either through new error with the error value, or you can decide to console.log it. So depending on how you want to handle this error. So like I said, using async is just a syntactic sugar. This can still be done through the simplest way, which is using .then .catch. So yep, that's mostly it. I don't want to go into more advanced things to make it like easier to understand. I don't know if maybe I moved too quickly because I'm supposed to spend like a lot of time like buttressing on what promise is, but you guys can do more reading on it. The whole concept of a promise is, it's just a placeholder. So when you generate your promise, it lives in a placeholder. For instance, this is the promise we generated. This promise function now becomes a placeholder. It becomes an object. Now, how we choose to consume the promise is up to us. If this was returning an array, we can decide to maybe split that array into two parts. We can decide to maybe filter out some values out of the array. Is up to us. So fundamentally, promise is just a placeholder. Yes, okay, to answer these questions, real life example of where promises can be used is fetching of API. It will be difficult to depict this, but let me see. I don't have an API endpoint here, but I would have showed you like a good example. Let's see. We can go to MDN's document. Can you guys still see my screen, please, before I go ahead?
Yes, we can.
Okay, so I've switched screens, so I don't know if you can still see it.
You know, it's
So
blank.
I'm trying to, okay, it's blank now. Okay, I'm going to, let me just copy the code and probably paste in my Visual Studio Code. So this is an example of a real life promise. Like we are trying to fetch, say, list of movies using this API. So this http example.com/movies.json is actually an API. So if we hit this API, it's supposed to generate a list of movies in an array. So like I said, this part of the code it's a promise. Now, for us to use our promise, we have to do this .then we'll convert the results of the initial promise into a JSON, and we can either console.log it or probably consume it in any other way, maybe filter out some result as I've mentioned earlier. And we can still go further to say .catch just in case there's an error. And we can say, in case there's an error, just console.log the error. So we can still do this. So this is a real life example of what a promise is. I hope maybe I'll be able to, maybe given another opportunity, I'll be able to like focus more on promises, because that's the whole concept of asynchronous JavaScript. Is more promise based. Like everything you're dealing with, it's a promise. So you first of all create your promise. Your promise is, in a real life situation, your promise is you make an API request, and it first of all returns a promise. And then that promise, you can choose to do whatever it is you want to do with that promise. Any other questions?
Okay, guys, so if you have question, please drop it on the chat, or you can raise your hands, please. Okay, I think someone just dropped a question, Yemi, on the chat.
Yes, yes, you can only use one catch. You can't use multiple catch. I mean, one catch catches literally all the errors. It's not like, it's one catch is enough. One catch is enough. You can do multiple thens, but you just need one catch. So one catch catches all the errors. So once there's an error, once your program fails, then your catch kicks in. But you can use multiple then to keep mutating your data to whatever you want it to be. So that is why you can have multiple then. You can, because what your then does is it just returns a callback. So if you have, maybe if you want to process your data, like here now, here the data is being transformed into a JSON. That is what happens in this first then. In the second then, I'm telling my callback to log my data. But what if I want to do something else? What if this data is a set of numbers and I want to multiply the numbers by 2? I can also say .then, and I will say data, and I can say multiply. I can say data. I'm assuming it's an array .map. Then I can say item, multiplied by 2. So now this will return, if this is an array of numbers, it would multiply each number by 2. So now we have a new array entirely. So we can have as many then as possible depending on what we choose to do. But one catch is just enough to catch all the errors. So I would, I really wanted to gather some links to share with you guys for you guys to do more reading. I don't know how I'll be able to send it out. So that's just a challenge I'm having. Maybe the moderator of this session can reach out to me and I will find a way to get out all those links for you guys to do more reading and study on.
Okay, yeah, definitely. Mr. Maka will reach out to you so that you can provide us with the link. Okay, then please, if you have more questions, you can drop it on the chat.
Yeah, so thank you guys for your time. I really appreciate the audience. And yeah, I know it's usually quite tricky, like taking programming classes like this. Probably subsequently, if I have the opportunity to take you guys, I will have more robust examples that we could quickly run through and probably maybe just go into more coding stuffs from. Yeah, sure. Sure. I will share the slides. Probably I would share, I don't know how you guys would get it, but I would add more content into the slides, links that you can do more reading on, and some of these examples, especially the ones that I used for this class. I can just add them to the slides and share with you guys.
Okay, thank you so much, Brian, for today's class. Thank you. Yeah, so everyone, the slides will be available. So I think Ms. Amaka will share it later on for you guys. So you'll be able to go through it and read. Yeah. Thank you guys so much. I don't know, Ms. Amaka, is she on the call? Okay, she's not on the call. Okay, I think she's just joining. Yeah, I think that will be all for now. Yeah, Marvelous, please, do you have anything to add? I think he's on the call also.
No, nothing from my end. I mean, I really enjoyed the session. Thank you much, Brian.
Yeah, thanks, guys. Thanks. I appreciate.
Okay.
Okay, thank you so much, Brian. Thank you guys for joining. Okay, I think that will be all for now. Thank you so much, Brian. Thank you.
Yeah,
Okay,
you guys-
good night, everyone. Bye,
Yeah,
guys.
yeah.
Thank you.